Okay, so now that we've talked a lot about quadratic equations, now we need to know when we can use these to solve problems. So I'm on page 16 in your packet, and we have problems such as these that you might see. So it says the length of a rectangle is 1 more than twice the width. So 2 times w plus 1 is equal to the length, and then w is going to be my width. And it tells me the area of the rectangle is 21 centimeters squared. So you know that the area is equal to, of a rectangle, is equal to the length times the width. So I'm going to have w is my width, and then I had 2w plus 1 as my length. So I'm going to set 21 is equal to 2w squared plus w. And I notice, hey, this is going to be a quadratic equation, but I need to get my 21 over on this side and set it equal to 0. So then I may be able to use x factor, or maybe the box, x in the box, or the quadratic formula to solve for what my w is. So I'm going to subtract 21 from both sides. It's going to equal 0 is equal to 2w squared plus w minus 21. So in this situation, I have a quadratic. A is not equal to 1, so I can use my x in my box method to solve. So I'm going to say this is negative 42 w squared, and this down here is 1, and so I have 7w, and I have negative 6w. And I know that my first term is 2w squared, my last term is negative 21. And I'm going to plug in 7w and negative 6w into my box. So common factor of 2w squared and 7w is w. Common factor here is negative 3. My first value is negative. Common factor here is 2w. And common factor down here is 7. So whenever I factor it out, it's w minus 3 times 2w plus 7. And if I were to factor this back out, it would equal, or FOIL it back out, it would equal this. So now I want to solve for what w can be. So I'm going to set each of them factors equal to 0. Now, I know that length cannot be, or width cannot be, a negative number. So if I come up with a negative number, that can't be my width. So I'm going to add 3 to both sides to make it w is equal to 3. And I'm going to subtract 7 from both sides, so it's going to end up being 2w is equal to negative 7. Well, that's going to equal a negative number. So right off the bat, that doesn't make sense. But it probably makes sense that w is 3. Because if w is 3, then I know that my length is going to be 2 times 3 plus 1 is 7. And then when I multiply 3 times 1, it's 27. So the next situation that we have is the length of a rectangle is 3 less than twice the width. And then my area is 20 centimeters squared. And so kind of the same situation. So then you can solve it exactly the same way. Then we have a situation where we are going to maybe, I know there was a situation where we had something in our book where we had, not in our book, in our diagnostic test, that may have looked something similar to this. This is the same thing that we did before. I'm on page 18, and we can solve it. I'm looking to see if I can find one that looks like one that's on our diagnostic test. It doesn't look like it, so I'm going to make one up. So on our diagnostic test, you were told that you had a rectangle and maybe the area is equal to 42 centimeters squared. And I know that, well, I didn't know it was 42 centimeters squared, so I'm going to erase that. I have an area, or I have a rectangle, and the area is equal to, let's say, x squared plus 5x minus 6. And I know that one of the dimensions is going to be x minus 1. So my length is equal to x minus 1, and I need to know what my width is equal to. So I know that area is equal to length times width, and I know that that's equal to this quadratic. So if I already know that one of them is x minus 1, I'm assuming that maybe when I do the x factor, that one of them is going to be that. So let's see. I have negative 6, I have a positive 5, I have a 6 and a minus 1. So here it's going to be x minus 1 and x plus 6. So I know that w has to be x plus 6. So those are my two different dimensions, and that's one like that was on the diagnostic test today.